All right, let's talk about subsetting atomic vectors. A lot of this is based off of chapter 4 in Hadley Wickham's Advanced R book in subsetting, so I recommend reading that. It is an excellent book. Okay, so what we want to do is we want to be able to subset a vector, meaning just select a portion of it. And so here we have this simple vector x. It's got the values 2.1, 4.2, 3.3, and 5.4. And you'll notice that the value after the decimal, the 0.1, 0.2, 0.3, 0.4, correspond to its position in the original vector. So that will just kind of help you keep track of things. There's a few ways you can subset a vector. You can use positive integers, negative integers, also logical vectors and character vectors to subset a vector. So let's take a look at each of these methods. So subsetting with a positive integer basically returns values at that position. So here I can say, give me the third value and the first value. So you use square brackets, you do x square bracket, you put in the vector 3, 1, and that will give you the value at the third position, the value at the first position. Okay. There is a function called order x. Order x returns the values that the indexes that you would need so that if you were to subset x using order of x, okay, it will put the values of x in order from least to greatest. So it says if you want to put these in order, you'll need to select the first value, then the third value, then the second value, then the fourth value. And if you select the first, third, second, and fourth in that order, you will see you have basically sorted the vector. If you select values like the same value multiple times in the vector, so if you say select 1, 1, it's going to select that thing multiple times. So you'll get 2.1, 2.1. If you put in something that's not an integer, okay, R is going to just silently truncate these. So it's going to just do 2.1 becomes the second value, 2.9 becomes 2. It's not rounding, it just truncates them. So you shouldn't do this, but if you do some kind of calculation where you end up with a floating point number that's not exactly the number, let's say you get something like 1.999999999, and it looks like a 2, but it's not actually a 2, and then you subset using that number, you're going to end up selecting the first value. Now, in general, when you subset using integers, you should make sure they're integers. But yeah, if you're using like a floating point number and it's something like 1.999999999, and you think it's the number 2, it's going to get truncated and it's going to select the first value. You can omit values by using negative integers. So if I say x and then I put square brackets minus 3, 1, then we're going to select everything but the third and the first values. So we end up getting the second and fourth values. Now you can't mix negative and positive integers because that's just weird. You're saying I don't want the first value, I do want the second value, and then it says, well, what do you want with the third and the fourth values? Do you want them? Do you don't want them? And so R will error out if you try to mix negative and positive values into the same kind of vector here. So you can kind of negate, you can put a minus sign in front of the entire vector, and that will remove those, or you can just create a vector of all negative values, but you can't mix negative and positive values. Another very common way of subsetting a vector is using logical vectors. Logical vectors are basically true and false values, and it will return values that correspond to the trues. So here I have x, again, these 4 values, and I've got a logical vector with true, true, false, false. And so, of course, it's going to get the values that correspond to the true. It's going to omit the values that correspond to false. So it's going to get the 2.1 and the 4.2, and it won't get the 3.3 and the 5.4. All right. Here, I put in a logical statement, okay, a statement, a comparison operation that results in a logical vector, x greater than 3. X greater than 3 is going to return false for 2.1 and true for the other 3 values. And therefore, it does not return the 2.1, and it returns true for these values. If you give it a logical vector that is shorter than the vector that's being subset, it will be recycled to be the same length. So here I've got x is true comma false, or subsetting a vector that says true comma false, and so this is going to get recycled to basically be true, false, to kind of match the length, and it's going to give us 2.1 and 3.3. Okay. If you have a logical vector and you have an NA being the missing value, then it will always correspond to giving you an NA. So here I have true, NA, false. So we're going to get 2.1, 4.2, NA, and then we won't get the last value, 5.4. If you do something like true comma NA, then it will recycle it to true NA, and you'll get 2.1, NA, 3.3, NA. If you subset and you put nothing inside the square brackets, that will always return the original vector. Now, generally, you don't do this by itself, but it is very useful for something like subsetting a matrix or a data frame and arrays, because you will have, like, I want these select rows, but all of the columns or something. So you might just leave nothing there. Okay, so if you just do x square brackets, you get everything. Anytime you put a 0 inside the square bracket, okay, you're going to get a 0 length vector, right? And again, this is not something you do on your own, but a lot of times when you want to kind of test out your function, you want to make sure it's still going to work with a 0 length input or something like that. And so you can kind of create test cases by using x square bracket 0, and that you'll get a 0 length numeric vector, or 0 length vector of whatever it might be. Okay, and this again, we had an example in one of the earlier videos where we had a condition that just didn't apply. If I said a subset to give me where x is greater than 7, okay, all of the values would be false, and you would get a 0 length vector there. If you have, if you've set names to your vector, okay, so here I'm going to set the names of x. I'm going to give it the names a, b, c, and d, and I'm going to store that as y. And if you have a named vector, then you can subset the vector using a character vector with the names. So you can say, I want the names d and c and a, and it will give you those values in order, in that order. Like integer indices, you can kind of repeat them. So you can say, give me a, and you'll get 2.1 multiple times. When you subset using this, the spelling has to match exactly. So here, if I have a vector z, and the name is ABC, and the name is DEF, and you say, hey, subset on A or subset on D, you're not going to get a match, and you're going to get NAs there, okay? And so if you have something just spelled a little bit off, right, you have a capital A, B, C, or something like that, and you put in lowercase ABC, you're not going to get a match. So you have to make sure things are matching exactly there. A handy little thing is creating a little lookup table. All right, so here I've got a character vector, and I've got M, F, U, F, F, M, and M. Okay, and let's say I want to kind of replace all of these things, so that instead of M I have male, and instead of F I have female, and instead of U we're going to put an NA. Okay, and so how can I go through and replace all of these things? All right. Well, what I can do is I can create a small vector that kind of corresponds with the lookup values. And we're going to basically say when you see, we're going to put in the values that we kind of want to replace them with. So we'll put male, and we'll give it the name M. We'll give female, and we'll give it the name F. And we'll have NA, and we'll give it the name U. And then I can subset lookup, okay? Basically, I'm subsetting my small vector with the kind of desired values. This is a vector of only 3 values in it, but I'm going to subset this vector of only 3 values using the longer vector x. Okay, and remember, R is able to kind of handle repeated values here. So when it subsets here, it's going to look up using kind of the names. It's going to put in the M and it's going to retrieve male. It's going to find the F, it's going to retrieve female. It's going to find the U and retrieve NA. It's going to find the F again, retrieve female, find the F again, retrieve female, and so on and so forth, and it does that. So this is what happens when you subset the labeled or the named vector, the short named vector, with basically the vector x. Okay, and then if we want to get rid of the names, then we call unname on that. So we say unname, look up x, and now I have replaced all of these things, in accordance to there. So so that's a handy little application of the lookup table. This is a hint. I'll say you can apply this to one of the problems in your homework assignment, the one where you're doing month names. You can kind of frame it as a lookup table, and I think that's a fairly elegant approach to the problem there.